Hello, everyone, and welcome to today's SANS webcast, Network Detection and Response with Open Source Tools, sponsored by Corelight. My name is Jessica Gallus of SANS, and today's featured speaker is John Gamble, Director of Product Marketing at Corelight, and will be moderating today's webcast. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be made available for viewing and can be found in the SANS webcast archives. And with that, I'd like to hand the webcast over to John.
Thanks so much for the introduction, Jessica, and welcome to today's webcast. Thanks for joining me. I'm really excited to knowledge share with you folks. I expect some of you are probably already using some of the tools we're going to discuss and might have contributions for the audience to discuss. We'll hold Q&A until the end, but please type in questions if you have them in the box, and I will look at them, and we'll save some time for Q&A at the end. I did a session last week that we had some great Q&A with SANS audience, so I'm hoping for more of the same with you folks today. And lastly, I'm going to try to keep this on the shorter side. I mean, we spend all day on Zoom and webinars these days, and I know that everybody's got a busy day. And so I'm going to try to keep this on the closer to the 30-minute mark. We've got 30 slides, so trying to keep it tighter than an hour, and we'll see how we do. So let's get started. Network detection and response with open source tools. That's the topic of today's discussion. A little bit about myself. I'm Director of Product Marketing here at Corelight. I've spent my whole career kind of in the cybersecurity field, representing products across a range of different areas, from endpoint to network. You know, I like to think that I'm a fairly technical person for a product marketer. You know, I've got my hands dirty with Wireshark on my first job 11 years ago and sniffing packets, and I continue to try to get my hands around the tech that I'm representing. So I'm sure some of you on the phone today are more technical than I am and probably know some of these tools better than I do, but I'm kind of here to provide an introductory overview of this topic. And if you've got knowledge to share, please share it in the chat or ask a question, and we can discuss at the end. So the agenda today, I want to talk about kind of an open network detection and response framework built on open source tools and what that entails. I want to discuss some of the benefits, as I see it, of this approach to network detection and response, because of course there are alternatives. You can go with, you know, a private kind of closed system vendor solution here. I want to dive a little bit into two tools today on the kind of NDR stack that we'll cover. We don't have time to cover all the tools, and there are literally dozens of tools you could be using. So I'm just going to focus today really on Zeek and Suricata from the open source toolkit at greater depth, although we will discuss some of the other tools as well in the first two sections. Then I'm going to tell you a little bit about Corelight, today's sponsor, and kind of how we fit into the picture here, what our NDR platform offers you with respect to some of these technologies and capabilities we're going to discuss. And we'll close on Q&A. So let's get started. So, right, you signed up for today's webinar, so I assume you're either interested in or actively kind of contemplating a network detection and response strategy, right? And, you know, NDR is not a firewall at your perimeter, although that's a helpful part of your network defenses. That's not kind of a comprehensive way to monitor and defend your network. You know, firewalls are exceptionally good at looking for specific things at the perimeter and blocking them appropriately. They're not going to really help you for data center traffic, for example, east-west traffic internally and understanding if somebody's laterally moving in your environment. And even on the perimeter, they're not going to catch everything, and they're not going to provide you visibility across all of the protocols and traffic activities that you're interested in. Again, an important tool, but not sufficient today for kind of comprehensive network defense. So, you know, EDR, right? Many of you probably have EDR solutions deployed. And the point I want to make on this slide is if you haven't deployed a network detection and response solution, i.e. a holistic approach to monitoring and defending your network, I would encourage you to strongly consider moving that up your priority list, because truly, you know, you have some significant gaps in your environment if you don't have NDR in place today. Notably, right, network offers you max visibility of your environment in terms of breadth. You only are going to get endpoint coverage for the agents you've deployed on those particular endpoints. But of course, achieving 100% agent coverage is sort of a dream that's never actually achieved in any sort of organization of larger size, as well as a number of devices you're just not going to be able to touch with EDR agents, whether that's IoT devices or kind of servers internally that you need to be monitoring. There's just a whole range of activities that EDR is not going to capture. And so you need also to have breadth of visibility, right? You're looking for patterns across your environment, and the network is kind of that zoomed out view that gives you that breadth of visibility. And also the network, right, can't lie. I mean, adversaries do all manner of things to try to disguise what they're doing in their network traffic. They'll encrypt it. They'll hide in plain sight in your DNS traffic and try to exfiltrate data over DNS. They'll mimic existing communications, legitimate communications from some of your internal tooling, which is actually something we saw with the SolarWinds attack. There's all manner of tricks, right? But at the end of the day, they have to push packets. And if you're there with a platform to capture, parse, make sense, and analyze that traffic at scale, those packets ultimately can't lie. You've captured them, and that's a permanent, immutable record of what happened on the wire. And analyzing it means that you're going to get to the bottom of the truth eventually. And on the EDR side, that's not always the case, because when endpoints get compromised, telemetry gets compromised, and it becomes a fundamentally unreliable provider of information about your environment if your endpoints get compromised. And we've seen that too, right? Again, I'll refer back to SolarWinds, specifically looking for evidence of EDR presence on the device and going silent if it was discovered. Endpoints are excellent, and you absolutely need both. This is 3 legs to your stool, but I just kind of wanted to start here because I'm not sure where the audience is in terms of their NDR rollout strategy. And for those of you that are at the beginning stage of consideration, I strongly urge you to kind of accelerate that adoption, because there's some significant gaps that should be closed. So let's talk about the components of building an NDR strategy, right? Let's imagine that this kind of represents, the wire, the traffic, right, that you're looking to monitor here at the top. Well, you're going to want to hang some sort of detection technology off of that, right? Humans can't scale. We can't find all the bad things. We need algorithms, whether those are signatures, simple signatures, more complex behavioral rule sets, or actual machine learning based algorithms, some sort of detection technology to scale in your environment. You're also going to want to be able to draw evidence off of your network traffic. And evidence is data about the activity on the wire in a usable, storable format that makes human sense, right? Because as a human security analyst, you're going to want to be able to say, oh, I just got this alert over here. What actually happened? Well, you need evidence to do that. You may also want to invest in packet captures, right? Actually capturing 100% of the fire hose and storing it to disk and analyzing it. Now, with those kind of components in place, next you're probably going to want a data lake, a single source to put your detections and evidence. Typically, that's a SIM. And on the packet side, you need an analysis tool, right, to actually look at tear apart those packets and make sense of them. And advanced shops may want to add orchestration and automation capabilities, right, on top of this. And if you look at all of these components, kind of this is the basis of kind of the core components of technologies that you might see in an NDR platform you're building. But today's topic is about open source tools, right? Can we achieve what I'm showing you here using just open source tooling? Yes, definitely. I'll just give you one example. There's dozens of tools. This isn't a definitive list that I'm giving you right now, but this is just an example. We can fill these boxes. Watch. Suricata, open source, battle-tested IDS, IPS technology, widely deployed and loved. Great open source network-based threat detection technology. Maybe you want to add some threat intel too to your detection strategy. MISP, great open source threat intelligence sharing platform. Evidence, how do you actually validate your investigations, the alerts rather, during the course of your investigation, or proactively look for evidence of malfeasance on your network? Open source Zeek, Zeek Network Security Monitor, been around for decades, used by some of the largest SOCs in the world to defend the most at-risk, highly attacked networks, a favored tool of top blue teams worldwide. Packets, Archemy, you may know them by their former name, Moloch, recently renamed, an open source packet capture and analysis platform. SIM, right? Elastic has an open source, free version of their SIM technology that you can use and spin up in your own environment. SOAR, the Hive. This might be a new tool. Some of you may have used it, but this might be a new tool to some of you on the phone. Again, orchestration, automation, response capabilities in an open source platform. This is just one example. Again, this isn't a definitive kind of design pattern, but it's one design pattern that I've seen out there in the wild that customers use. And it's just proof that you can build an open source technology-based NDR strategy. So what can you expect at a high level? Now, I'm going to assume there's a range of experience on the phone. People that have never deployed any open source technology in their security operation, to people that are experts in one or more of the tools that I just listed, or other tools that I didn't mention. But just to kind of level set, kind of what does it require to actually implement technologies at the high level here? Well, yes, open source is free, and that's awesome. And open source is open, which means you can modify it, and that's awesome. And open source has a community behind it, which means you get support and the projects move forward because other people are helping to develop and extend and push the capabilities. All awesome things for open source. But in terms of the rollout, it's a commitment, and you should be ready for that commitment, right? It's typically a BYOH situation where you're buying your own hardware and installing these tools on top of that hardware. You're kind of tuning, debugging, dealing with packet loss, edge case issues as you're experimenting it within your lab and rolling it out into production scale. From an intelligence perspective and a detection perspective, you're going to want to pick your open source tools there in terms of rule sets or detection packages or open source intelligence and install and integrate those into your systems. Now, if you're a relatively small shop or just wanting to get this started in a home lab for your own experimentation, you're talking about probably hours to days to get a basic deployment of kind of a core set of these tools up and running in a small lab environment. If you're an enterprise, this is a weeks to months long commitment to get this stuff rolled out. There's no shame in that. I mean, I've talked to some of the largest security teams at the world's largest companies who use some of these tools that I mentioned, and it took them on average months to, in some rare cases, even years at super large organizations to get this stuff fully tuned and deployed at scale. It's a journey, but again, it's always a journey with security tooling, right? Even if you're buying off the shelf commercial, there's always a rollout period that can last from weeks to months, depending on the technology. But just get ready for that in the open source world. And then there's kind of the ongoing care and feeding of the system, right? Because these are open source tools, it's kind of incumbent on you as the operator to make sure that they are staying updated in terms of their operating system, so they're secure. Making sure that the rule set and intelligence is curated and recent, and just generally doing ongoing maintenance and monitoring of the entire platform itself. Because again, you've rolled this stuff on your own hardware, most likely, and it's up to you to make sure that it's functioning correctly and that you're not dropping 30% of your traffic in a key data center, right? That's a responsibility that comes with open source because it's not a commercial tool set, so there isn't kind of built-in high fidelity cross-platform monitoring. Those are things that you have to kind of pay attention to. And so, I've seen one person at mid to large size organizations do this all themselves and still have time for their analyst kind of day-to-day responsibilities or security engineering or security architecture capabilities. It is possible. Of course, there's a learning curve, right? I'll give you some links so you can do some more reading yourself, but you're going to have to go to GitHub. You're going to have to read some documentation. There's certainly a learning curve that you're going to have to climb before you begin your rollout. But once you do, it's extremely rewarding. And that's part of the joy of my job, is getting to talk to people in the security world who discovered these tools long ago and just absolutely love them and can't imagine a world without these capabilities at their disposal because they know that it made their security life so much better. And that makes the process you see here worth it because it ultimately improves workflows, makes you more secure, and makes you more effective at your job. So what are some sample use cases that we could draw out from kind of this open source NDR stack, perhaps using some of the technologies that I mentioned on that screen? Well, it's going to allow you to investigate, triage, and ultimately resolve validated alerts quickly. In the case of just using a firewall and maybe some NetFlow logs and maybe a couple other kind of server logs you're able to pull into a SIEM, you might find that pretty challenging, right? To be able to make sense of, is this a valid alert? How did it happen? Why did it happen? And what's the remediation path? That can be tricky if you don't have good cross-network visibility. But with a toolkit like I outlined on the prior screen, this becomes quite feasible. So very specifically, let's imagine that you installed the Emerging Threats Suricata rule set, which is an open source, freely available, curated Suricata rule set. You've installed Suricata in your environment. So you install that rule set. you come into work on Monday, a new alert fires. You take a look at the alert, and now you're going to the investigation. You're trying to validate that alert and understand what's your course of investigation or remediation. Well, you've also installed open source Zeek, the network security monitor that takes all of your network traffic and turns it into usable evidence. So you can quickly pivot across port and protocol. You can answer all the questions you have about that alert. What did this connection do after this alert fired? What did it do before? What protocols did it cross? And what activity occurred? All of those questions answerable in Zeek. And you're perhaps using Elastic here, right, to analyze that Zeek evidence and that Suricata alert. So as an analyst, you're sitting in Elastic, you're looking at that Suricata alert, and then you're pivoting into your Zeek logs to understand, yep, this is valid. Here's the remediation path. Initiate the remediation path and close out the ticket. I've seen analysts save, on the order of 20 times faster kind of acceleration in their incident response workflows when they adopt these kinds of technologies versus, kind of relying on visibility and evidence where you can get it on your network and detection technology that's kind of black box and hard to parse. That just leads to unresolved tickets that get closed, and nobody likes that. You can also effectively hunt for threats in your environment once you have a system like this up and running, right? You're probably familiar with the MITRE ATT&CK framework. Well, you can take that attack framework as a guidance on how to think about threat hunting. Maybe you zero in on a couple TTPs in the command and control column, and you say, you know what, I want to figure out if we have C2 activity going on in our environment. I want to look at these specific techniques, and you develop a thesis of how you might discover those techniques by searching through your evidence. So you build those hunt queries. Maybe you're looking for repeated beaconing activity. So your query is based around timing. You're looking for kind of very regular repeated communications going out. And so you set your hunt query to look for those kinds of behaviors to surface connections that are basically exhibiting beaconing behavior as a potential thread to pull on. Well, you build those queries again, maybe in Elastic, you save them, and you can run them regularly. And so you have an ongoing kind of hunting trap that you set that you can revisit periodically to look for evidence that's surfaced and dig deeper if you think you found an interesting thread. And then on the last two there, right, creating custom detections and reacting rapidly to kind of new zero days. That's really the power of open source, right? The idea that these are open platforms, they're open to your inspection, they're open to your modification, and they're open to the community's modification, which means you get to ride the wave of the community. So maybe in-house you don't have the ability currently to create custom detection engineering using Suricata or Zeek or Elastic, or maybe you have one person, but you've got a community behind you. And so when new things happen and major security breaches are announced with new zero-day exploits that have never been seen before, the communities behind these tools spring into action. And I'll show you a very specific example of that in a few slides. It's not an empty proof point. There are a number of examples, recent examples of this in play. And it means that you, as an organization, when your CISO is kind of breathing down your neck and saying, hey, the board is asking me about this massive breach that just hit the news cycle globally. What are we doing about it? It's not just you and your team. You've got a community behind you of people that are working to build detection engineering and IOCs and all of that great stuff. And I'll give you a very specific example of that later in this presentation. So here are some resources. The slides will be shared so you can have access to this, but this is where you can dig in and get some more detail about some of these tools that I've mentioned here. I also want to flag, oh yeah, actually, let's go to a quick poll here for a second. So I'm curious, and unfortunately, I'm only able to ask kind of offer you 5 options. I would have liked to have asked more, but these are the 5 I'm interested in. If you could just take 30 seconds here, and I'm curious of the audience, which of these open source tools below have you used before? Let's give people 30 seconds. All right, let's close the poll. Okay, let's see here. We have got poll results. Wow, all right. 3/4 of you have used Wireshark. I count myself in that group as well. As I mentioned, that was one of the first tools I ever got exposed to in my first job, and I got to sniff packets crossing from mobile applications back to their servers. So I got to use Wireshark. So 3/4 of you have used Wireshark. 5% say you have used Suricata before. About 7% have used Elastic, 6% Zeek, and 6% none of the above. All right, so it sounds like we have a lot of people on the line that are familiar with packet capture and packet analysis technologies, namely Wireshark. So, with that in mind, I'll bring up some more interesting content we can discuss in the Zeek section, because if you're not familiar with Zeek and you are familiar with Wireshark, I've got some great news for you. Lastly, on this slide, I want to point out Corelight's threat hunting guide here. It's freely available for download. Again, these slides will be available. It is a 40-page guide that provides queries mapped to the MITRE ATT&CK framework, built around Corelight logs and open source Zeek logs. And so you can take that guide and you can actually use it to get started on your threat hunting journey, because we've basically given you the technical guidance on the queries we believe that would be helpful to discover kind of TTPs in your environment. And I also want to point out a shout out to SOC Prime. So they are a marketplace. It's a vendor, so it's not an open source technology per se. But SOC Prime does a lot of great work supporting open source technologies, and in particular, they have a threat detection marketplace, which is free to register for. And in that threat detection marketplace, there are dozens, hundreds, thousands of Sigma rules, which is a cross-SIM query language, which basically means you can take a query and it'll translate it into your SIM of choice. So that's a really awesome technology. We actually worked with the SOC Prime team to develop Sigma rules based on the hunting queries in our guide. So I want to point that out, just because if you're an Elastic user currently, for example, and you use Zeek, or you're interested in using Zeek, pop into the threat detection marketplace on SOC Prime, register for a free account, and these rules are freely available, where we've actually taken the guide and actually delivered it in the form of pre-built cross-SIM queries. You could just take the Elastic queries and drop them right into your Elastic SIM. Let's keep moving. So we did that poll, excellent. Let's talk about some of the benefits of why you would want to take an open NDR approach versus perhaps a commercial all-in-one platform from a kind of proprietary system point of view. Well, there's definitely convenience in the all-in-one off-the-shelf platform, right? There's certainly convenience, but there's also cost, and I believe that cost comes in the form of a strategic choice that you're making as a customer. If you're going with a solution that's fundamentally proprietary and closed versus something that's either open source or based on open source technology. And that strategic choice is about who controls your data and your detections. On the closed side, if you're going with an off-the-shelf vendor who's got a proprietary NDR system, they ultimately own the data and the format, and they ultimately control the detection strategy. For some organizations, that may be preferable, but do recognize that there is a downside to that kind of choice, which is that, for example, let's imagine, next quarter, for some reason, your team needs to analyze a specific protocol. It's a high-value protocol, maybe it's proprietary to your environment, and the vendor that you've chosen for NDR doesn't have that. Well, that's a feature request. That's their product management team's job to get that into their kind of priority list and deliver through their engineering team. You might get it, but that's kind of your only option there, because you yourself aren't going to be able to engineer their system, and it's solely dependent on them to be able to provide you that coverage. Or maybe a new 0-day is announced tomorrow, another global headline-making event, and your team's scrambling. Again, your CISO is kind of putting a lot of pressure on your team, and you're trying to figure out, okay, were we affected, and how do we detect this thing going forward? Again, you're kind of single-threaded there on the vendor. Now, your vendor might be fast, your vendor might not be fast. It might take them a couple days, a week or two even, to build in some of the detection engineering to be able to detect this on their platform going forward. So when you choose an open NDR strategy based on open source technology, you give yourself that control. You put yourself in the driver's seat, and you get to make those choices because they're available to you, because it's an open system, right? You can reach out to a community and say, hey, I'm trying to monitor this specific protocol. Does anybody have any advice? And they might say yes. You could use this log over here to get some visibility into that particular stream. And actually, you should check out this work over here because these folks developed a protocol parser that's related to the protocol that you're interested in. And if enough people want it, the community jumps into action. And we've seen this time and time again of communities sharing this kind of information. A very specific example is Amazon. They're big open source Zeek users, and they released about five different ICS related protocols to the community for free that they developed in-house for their team. So that kind of community giving propels the kind of capability set in an OpenNDR platform forward continually because you're not single threaded there on one vendor. So that's how I see it. You know, when I look at these choices before every organization, I think each organization should carefully consider kind of the strategic implications of the choice. Because if you want to rip and replace your solution down the road, it gets a lot harder on the closed NDR side if you're not happy with the service or the kind of delivery of the platform in your environment. Again, let's kind of dig a little bit deeper here on the benefits of why you might want to take this approach to network detection and response. I kind of look at it in terms of kind of two spectrums, right? Detection and evidence, right? Things that are bad and the evidence that can prove one way or the other and help you resolve or proactively find bad in your environment. And there's a couple different dimensions of advantage, I believe, that come with an open NDR platform, right? You maximize your exportability options because it's open source. It tends to be a lot more widely supported across a variety of security technology, proprietary security technology, right? You know, SIM vendors don't have a financial incentive to really strongly map to a data schema of a proprietary vendor. That's kind of a one-off. Unless it's a really big vendor, there's not a lot of financial incentive there for them to make sure that data schema from the vendor is properly mapping to their platform. But in the open source world, because so many people use it and so many technologies use it, you better believe those SIMs have a strong incentive to support that data set, and they do. And we can talk in more specifics in a second on that on the next slide. Extensibility, right? Because these platforms are open, you can write new rules, you can capture new data, you can modify the data that's being captured by default, you can inject new intelligence streams. There's just so much customization that comes from an open system that gives you and your team choices. A really cool specific example of this that I love, I was talking to an organization who took their internal kind of server kind of mapping and IT contact information, and they injected that into their open source evidence work streams, and they were embedding it in the logs themselves. So when an alert fired and the analyst pivoted into the log and validated it and said, yep, this is a problem, this is the remediation action I need to take, the name of the server owner and their email and phone number was already embedded into the log. It's a really cool example of workflow customization. It's just one of hundreds or thousands that have been done in the community. And I think it's a really powerful advantage to be extensible in that way. I'll call out maybe one or two more advantages, and then we'll go to the next slide where we'll dig a little bit deeper on two of these. You know, transparency of detection, I think, is really important. How often have you gotten an alert that you have no idea why it fired and you can't figure it out, and the vendor isn't even sure necessarily why it fired, and they get their support team on the phone and they try to debug it and they try to tune your system? It's quite common. You know, will you see alerts that don't make sense in open source world? Sure, but the difference is the detection logic under the hood tends to be readily transparent. You can look at the script, you can look at the logic, you can look at exactly why this thing is firing to understand what went wrong or what went right. You don't have to pick up the phone and contact customer support and say, excuse me, you know, we're getting so many false positives in this last week. What's going on? We can't figure it out. We need your engineers to get on the line. You don't typically have to do that in the open source world because you can look at the stuff yourself, or you can reach out to somebody in the community who might know as well. So just to go deeper on kind of two of these items and give you kind of very specific example, I mentioned like exportability and kind of choice and how important that is. The vendors on the left are just a sampling of dozens and dozens and dozens of security platforms out there that accept these open source data formats and alerts that we've just talked about. Because again, these open source tools are widely dispersed across many organizations for decades now, And so, of course, these SIMs, these analytical technologies, these file analysis platforms, these data lake technologies want to support that data because it's widely used and it's worth their engineering effort to ensure that it's supported. And so you just have so much choice as a SOC and as an analyst when you go with an open, fundamentally open source platform on the NDR side. How many of you are kind of in the middle of a SIM rip and replace or considering a SIM replacement? I bet it's more than a handful of you. People are always kind of looking to improve their security tooling and technology. In the open source world, that's a lot easier proposition because you can save your open source evidence to disk even if you don't have your new SIM stood up. You can save your open source alerts to disk even if you don't have your new SIM stood up, and then you can quickly import it into your new SIM once you stand it up and look through retroactively what you've stored, right? If you're going with a proprietary vendor, might be possible to export the equivalent data set out and get it into the new platform, but it's going to be tough. Those solutions are competitive. They don't want to make it easy for you to leave your SIM and go to another SIM, so they don't really support that freely and easily. And here on the right, vendor X and vendor Y, real vendors, that's list that you see there, that truncated list, that's their offering in terms of how you can get the data and insight out of their system. That's what they support. And so if you want choice, if you want to future-proof your SOC, I strongly believe that kind of an open NDR approach is the right approach here because it kind of avoids some of the vendor lock problems that can come with these proprietary solutions. So I mentioned kind of speed of response and detection and the power of community. The SolarWinds attack, referred to variously as Sunburst or SolarGate, right? The attack on the Orion platform, which is a network monitoring platform that SolarWinds offers, a nation state adversary most likely, very sophisticated attack, compromised the supply chain, and was pushing malicious code updates signed by the developers, authentic developer certificates. So very, very hard to detect. Got discovered by FireEye's research team, Mandiant, in December and published and kind of went viral quickly and made global headlines. And then something very interesting happened, right? It was a perfect case study, I think, of what I'm talking about here, of why detecting with a community based on open source tooling on the network side is a better approach. Within 24 to 36 hours of FireEye publishing that blog post on a Sunday night, there were open source Suricata rules freely available that detected a number of IOCs. There were freely available pre-built queries in Zeek logs to look for evidence of these IOCs. There were rules, Sigma rules, up in the SOC Prime threat detection marketplace that I mentioned. Again, free to register, free to download those rules. Very, very quickly, teams that were using these tools had hundreds and hundreds of kind of discovery capabilities at their hands built by the community that they could start instrumenting in their SOC. There were other organizations that didn't have these that were reliant on what I would consider kind of proprietary closed NDR systems who it took a few days and it was a tense few days. And even worse off were organizations that hadn't done anything about NDR and were struggling to even understand in those first 24, 48 hours, do we even use the Orion platform in our environment? They struggled with that simple but fundamental question before they could even launch their investigation because they didn't have comprehensive visibility across their network. Teams that have NDR in place can answer that question very easily because they can just go to their network evidence library and say, search for these Orion indicators. Yep, it's in this satellite office here, it's in this data center here, et cetera, et cetera. That query should only take a few minutes to answer for someone that's instrumented NDR. So I illustrate this as a spectrum, right? It's a great demonstration of the power of open source and aligning yourself in open source communities because you're not single threaded on your vendor, and you can respond a lot faster in many cases. I've seen open source Zeek packages literally released within hours of zero-day exploits making the news. Hours of free detection script that you could run in your environment to look for that 0-day and get back to your boss saying, yep, we've searched our environment. We don't have this that we can find in the last 6 months, so we can close this, right? That's the power. So let's talk a little bit about Zeek, a little bit about Suricata, and then a little bit about Corelight, and then we'll wrap it up. So Zeek, I've been kind of mentioning it across this presentation. If you're not familiar, back battle-tested 20-year-old open source network security monitoring technology. Used to be called Bro. You might have heard of Bro Network Security Monitor. Same thing, got renamed to Zeek about a year and a half ago. Zeek does three things exceptionally well. It takes your raw network traffic and knocks it down an order of magnitude in data size. So talk about 1% of your total traffic, and transforms it into usable security evidence in the form of comprehensive protocol logs. So you as an analyst can ask and get answers to fundamental questions you have quickly. You know, okay, an HTTP session was initiated. What happened next? Well, you can pivot to the DNS log. You can pivot to the files log. You can pivot to the whatever log you want within the framework, and you can answer those questions quickly. It's purpose-built metadata for security analysts to make fast sense of their network. Zeek also extracts and reassembles files, supports hundreds of different file types, so you can do file analysis downstream. And lastly, it has a built-in scripting language. You can actually write and create custom detection or monitoring tasks within the Zeek framework, and you can leverage the community, the open source community that's developed now hundreds of these packages that are now shared up on GitHub. So it's three fundamental capabilities in one awesome tool, extremely complementary to a number of the other open source tools that I showed you in that NDR sample stack. Right, Suricata alerts go really well with Zeek, and we'll talk about that in a second. You can pivot from Zeek logs directly into packets with precision. So you can actually quickly zero in on the packets that you need to dig into from your Zeek logs. There's a lot of great complementary force multiplication effects when you put Zeek in your environment. Kind of real quickly on the data, I mentioned this on the prior slide, but if you're not familiar, I think kind of the takeaway on Zeek data is it's comprehensive. It's all the data you need and none of the data you don't, right? So you don't want to be wading through information you don't need as a security analyst. There's over 400 fields in these logs, and every single one of them is there because a security analyst said that's valuable. And importantly, the whole logging framework is connection oriented, which means Zeek thinks in terms of connections, which is how analysts think about addressing network-based threats, right? It's connection-oriented activity. A lot of logging in the network space is appliance-oriented, right? These logs kick off your DNS server or your SMTP servers, but those logs are kind of fundamentally designed around IT use cases. In most cases, they're designed for performance, troubleshooting, debugging. It doesn't necessarily have the data you need as an analyst, and you're trying to assemble all of these disparate data sources into one. Zeek gives you everything you need in one format, and it's connection oriented, so you can pivot across these protocols and ports seamlessly, and that means speed. So if you're interested in getting started with Zeek, I've given you the URL there. There's a lot of great mailing lists and kind of activity. If you join the mailing list, there's a really active Slack channel that's awesome. Even if you're a newbie, great place to jump in and get your feet wet. There's regular kind of community calls where they knowledge share. And if you're interested in an enterprise grade version of it, you can come talk to Corelight. We'll talk a little bit more about that at the end of the presentation. But here's kind of some ways you can get your hands started with Zeek if you're interested. Let's talk a little bit about Suricata. So in the poll that I ran earlier, usage levels of both Suricata and Zeek were about approximately the same. So I'm going to assume most people on the call are not familiar with Suricata, much as they are not familiar with Zeek. So let's talk briefly about Suricata. Suricata is kind of a gold standard open source IDS, IPS tooling. Most of the deployments that I've seen, at least in the last few years, tend to fall more on the IDS side, less on the IPS side. So they're not being deployed inline and actually actively blocking. They're deployed passively and kind of creating detections off of that passive monitoring, although some people certainly do deploy it as an inline IPS solution. You know, its predecessor is of course Snort, and there's actual cross compatibility for the rule set as well. It's open source, of course. Primarily, the rule set logic is signature driven, and there's a range of rule sets out there. You can buy privately curated rule sets, but there's also community rule sets that are freely available. the emerging threats rule set, which is curated by Proofpoint, is an example. They have a paid version, but they also have a freely available open source community version as well, which is great. So that's Suricata. And let's just take a quick look at a Suricata alert just to kind of understand what we're looking at here, right? So it's giving you kind of a category of the alert. It's giving you a severity rating. It's showing the signature that was matched to that kind of alert. So if you're curious, you can actually dig into the signature itself and kind of look at the inspection logic to understand why it may or may not be a valid alert. And you're getting kind of metadata details about the kind of connection, right? The destination port, et cetera, associated with the connection for which this alert fired. So it's the starting point of your investigation. A Suricata alert is a great, fast, cheap in the sense that it's open source and free way to get insight and alerting technology on your network up and running. And from here, you can actually pivot into Zeek logs or packets to go deeper in your analysis as you're investigating these alerts. All right, let's talk briefly about Corelight and then kick it over to Q&A. So where does Corelight fit in this picture, right? We talked about kind of examples of open source technology that you might use in an NDR stack. We gave a kind of brief high-level overview of what the deployment and maintenance requirements are of such a platform. We talked about some use cases you might find. And then we dug a little bit deeper on Zeek and Suricata, which are two fundamental tools. Whether you're using those particular tools or not, detection technology and evidence about what's happening on your environment is a critical, must-have requirement of an NDR platform. So we dug deeper on two great open source tools in those areas. So where's Corelight fit in? Corelight is an open network detection and response platform vendor. We make commercial solutions that are built on these two technologies. And we offer a range of pre-built sensors that you can deploy across your environment. So it's flexible. You want to monitor AWS traffic? Great. We have a cloud sensor that runs in AWS that feeds off of the native VTAP that exists in the AWS ecosystem. You want to run in a containerized environment? Awesome. We have options there for you. You want to monitor a physical network? We have a range of appliances that can support, we've done deployments with customers in the 100 gigabits per second range. I mean, seriously large deployments. And our hardware has stood the test of time in those instances. And it's because we have an unfair advantage as a company. The people that built open source Zeek, and including people that contribute to the open source Suricata project, they work here at Corelight. So it's hard to beat the expertise in-house, and that's given us an unfair advantage in the kind of performance side of the equation when it comes to our sensors, amidst other advantages. We also offer a fleet management capability, so you can actually administer these sensors, right? I talked about the open source world where monitoring is kind of tricky, can get tricky with these open source tools, and we've made that really easy by having a central management console where you can actually see the CPU usage, the temperature readouts, the log rates of your various sensors in your environment, and also do role-based administration, policy administration, et cetera. So we've basically wrapped a really great commercial offering around really powerful open source technologies, and we've extended them too. It's not just performance benefits that you get by going with Corelight. We've done a lot of work to give you an N+1 solution. We didn't just slap open source on a box and sell it to the market. We've done a lot of work over the last few years to add these great N+1 capabilities to the platform that take these powerful technologies and extend the capability set in really dramatic ways. So I'll give you an example, two examples here of how we've done that in just a second. But just to reiterate about Corelight, right? It's an out-of-band passive deployment that supports Zeek and Suricata. So we're generating the Zeek logs, we're doing the file extraction, we're running detections. You can run Suricata alerts on our sensors. We can take and ingest your network traffic from both cloud environments and physical networked environments. So you would need a native VTAP on the cloud side, or a packet broker or optical tap on the physical network side. And then of course you're going to need downstream technologies to receive this data and analyze it or detect against it. A SIM technology, a file analysis platform, et cetera, et cetera. And the benefit we've seen from our customers deploying this technology, which is kind of also, of course, the benefit of Zeek and Suricata, is it unlocks really powerful new threat hunting capabilities. It dramatically accelerates incident response time and allows you to clear more tickets faster and kind of help burn down that backlog and get to high priority P1s. And it gives your team new detection and response capabilities that you wouldn't otherwise have, whether that's a community-driven detection for a zero-day exploit that comes out tomorrow, or it's a Suricata rule set that gets updated tomorrow with a whole set of detections based around, I don't know, say data exfiltration, right? It gives you those options because it's a fundamentally open platform built on these open source technologies. So we've taken the extensibility, the choice, the filterability that comes with open source and support that in our platform as well. Two quick examples of kind of the N+1 I was talking about what you get with Corelight beyond the open source. So we've done a lot of really cool work around extending the insights that the core Zeek platform offers in terms of protocol visibility. Zeek has an SSH log. It's great. It tells you a lot of details about an SSH connection without breaking and inspecting it. But our research team and our security engineering team have developed a set of over 24 unique Corelight insights that go beyond that SSH log and enrich it with really, really powerful insights for analysts, all without break and inspect. So we can give you insight into things like, it appears that a large file is moving across this SSH connection, or it appears that keystrokes are traversing this SSH connection, and it's not machine-to-machine communicating. Those little details might sound interesting, but when applied in the context of a security investigation, they become extremely powerful. We had a customer who was investigating a suspicious SSH connection coming from a country of concern when they triangulated the IP address. And with our enriched SSH insight, they were able to get a lot more detail about it, including that it was a human coming from that particular IP space, which further raised their concerns. And they were ultimately able to get to the bottom of it. But without those enriched insights, they wouldn't have known. And they probably would have closed the ticket without further kind of ability to get insight into the connection because they couldn't break and inspect it. So those are just two examples, or one example rather, of how we've extended the power of Zeek. And on the Suricata side, we've done something really cool and novel. As far as I can tell, I haven't seen any other vendor in the space that's offering what we've built here, which is that we didn't just put Suricata on a box, so to speak, next to Zeek. Our engineers thought long and hard about what would be the optimal integration of these tools and technologies because they're kind of like peanut butter and jelly. The open source world, a frequent design pattern you see is open source Zeek and Suricata deployed side by side because Suricata provides great signal and Zeek provides great evidence. And of course, those things go hand in hand. So our engineers kind of went back to the whiteboard and said, well, how could we actually make this, advanced beyond that simple kind of parallel deployment? And what they came up with was kind of a twofold innovation. One, instead of kind of dynamically pinning the two tools to kind of assign CPUs, which in the open source world is what you have to do. You basically have to estimate how much workload each tool will require, assign the workers, and then hope that your traffic mix doesn't change or that your throughputs doesn't change dramatically because it can start to fall down once those exceed your limits. They said, no, we can actually make a dynamically assigned CPU space where we can share the CPU workloads as needed across these two tool sets. So it's led to just dramatic performance capabilities that open source customers have seen and just said, wow, you've delivered an integrated solution of Zeek and Suricata that runs at speeds we can't match or even begin to match in our open source deployments. And that's because of the novel architecture. The other thing that our engineers did is they decided, well, if most analysts are pivoting into Zeek logs off of a Suricata alert, why don't we just natively embed the Suricata output into the Zeek data framework? Because that'll A, remove a pivot point for analysts, which over time adds up, and B, give the customer more control over data export and filtration if it's all within the same Zeek kind of data framework for export. And so those two innovations have again given analysts kind of an easier time because now with Corelight, a Suricata alert fires and the UID, which is the connection ID, is right there. And you can just click that and you can open up all the protocol logs to investigate that particular Suricata alert. You don't need to hop between the two tools. That hop is done for you. It's natively embedded right in the alert itself. So that's Corelight. That's what we offer. It's an open network detection and response platform that can accelerate your incident response capabilities dramatically, give you new threat hunting capabilities and new threat detection capabilities as well on your network. Of course, based on the power of these fundamentally kind of open tools, which is why our platform itself is open. We've got great customers all around the globe. I'm obviously biased. I'm in product marketing, but it's really a joy to talk to our customers. I love getting to talk to our customers. They love what we do and they love the data and the insight that these technologies in our platform gives them. I've got so many great stories I could tell about happy customers and how they've used this data and insight, but I won't belabor the point. Let's roll to Q&A. All right, got a great question here. A couple great questions here. Let me see if I can knock out the administrative ones first before we go out of time. Someone had an audio issue, but I take it based on the other questions, everyone else could hear me okay. Hopefully that was only an issue for that one person. I apologize that you weren't able to hear, but I think a recording will be made available afterwards, so you'll be able to do it. Yes, the slides will be made available, as I mentioned. Okay, let's dive into some of the other questions here. Here's a question. Could you give your opinion on the Security Onion tool and maybe compare contrast with the tools you listed? Thank you. Definitely. So as I mentioned, I picked a sample of tooling. It wasn't exhaustive by any means. There's dozens of tools you could use in your NDR stack in the open source side. Security Onion's a good example of that. So Security Onion is a open source kind of toolkit. It includes a lot of different open source tools as part of that toolkit package, including Elastic, including Suricata, including Zeek, including a few other technologies, and I don't want to misspeak, so I won't represent those, but basically it's a great kind of consolidated toolkit for everything in kind of one package. That's great. It certainly makes it more convenient for people that are just getting started with these tooling and technologies to have it kind of all in one place. The limitation that I've seen tends to come around performance and integration at scale. So I don't typically see larger organizations using Security Onion, although some certainly do, but on average, I just don't see that because they want finer control over the individual tools, and they can achieve that by kind of creating dedicated tool implementations of each of those tools themselves. And that gives them a lot kind of better control over performance and ability to scale with integrations. And so I think, in short, my answer is I tend to see Security Onion as more of a kind of entry level to some of these toolings that can scale to a certain point for some organizations. But when I've talked to larger customers, that's what I tend to hear, is that they used Security Onion in their lab, and then they tried to put it into production and kind of ran into issues at scale, and that they were looking for an enterprise kind of grade solution to these problems. But it's a great tool. It's certainly something that you can check out in your home lab right now and get exposure to these tools. Another great question here. Let's see. I'm an aspiring cybersecurity analyst. Awesome. Is it feasible for me to build a home lab using these open source tools, integrating Suricata, Zeek, and Elastic? What would be your advice to set this up? Thanks for taking the time to explain this session. Yeah, you can definitely get started in your home lab with the tools that you mentioned. It will require some hardware. It may require some tapping, basic tapping infrastructure, but you can get some kind of home routers that will offer this for a nominal amount. I mean, we're not talking thousands of dollars here. We're talking about maybe $100 or $200 for that, plus the hardware to run those tools might run you another, call it $200. So for a home lab setup of all of those tools, you could probably achieve that for on the order of between $100 and $300 in hardware. And the tooling is open source and free, and there's great documentation around all of these tools. So yeah, I really think you could get these tools up and running in your environment at home. I've seen many, people that are new to these tools do that. It's a great entry point just to dive in and say, what's running on my home network? All right, let's see. We've got a couple other questions here. I'm trying to be mindful of time. Let's see here. Let's see. Is it better to run Zeek Suricata on the same system or two separate systems to ensure performance is not impacted? On the open source side, my unsatisfying answer to that question is it varies, it depends. I've seen kind of both, but at certain scales, I've seen organizations typically run into performance problems in both kind of architecture implementations. That's probably not the satisfying answer you were looking for, but I would just say it depends. Both can work. What is your take on using open source? Here's a great question. What is your take on using open source tools in banking and financial sectors? Well, I can tell you I know of a couple Fortune 100 banks who use some of the tools that I mentioned. I won't call out names and I won't call out specific tools, but they're being used at that level of kind of organizational risk, kind of financial compliance kind of environment where you have to be very careful about the tooling that you use. I know that these people are using those tools now, and so I assume your kind of subtext of your question is that possible from a compliance kind of perspective? And the answer I have to say is yes, because I've seen it. So if you join kind of these open source mailing lists and communities and poke around, you will find your peers in similar industries, and they're going to be able to help you more in their guidance there. I don't have specific guidance on kind of the ins and outs of compliance in FINRA and open source tooling, but I do know that they've been overcome by some of the biggest banks that we all use on this phone. So I do know it's possible. Let's see here. Let's answer maybe one more question. Let's see here. Any guide on how to start building a lab to test these integrations of these tools? Yeah, there's a number of resources out there. So first, I would just say start with each of the individual tools websites. There's a lot of great documentation there, many of which is around integrating them with the other tools that I mentioned. So that'll be a good start. YouTube too is a really great resource. You'll find a lot of talks and technical tutorials of people integrating these tools. There's a lot of great security training organizations out there too as well. I think if you look at like the Black Hills folks that do great security training, they've got a number of pieces of content in their library about kind of getting started in a lab environment with technical hands-on guidance. So between kind of the primary tool sources, YouTube, and security training organizations like the ones I just mentioned, you're going to get enough guidance, I think, to get this up and running. If you're interested, I'll give you my email address at the end of this presentation. We have, for qualified organizations, we have a program that we can offer that can help people experiment with this in a kind of lab environment. It's sort of like a POC. I can't guarantee I can give you access to that, but potentially that might be an option as well. So my email address is there up on screen, john@corelight.com. Feel free to shoot me an email with anything. Sorry, there's a couple questions in here that I think are, I'm just not going to get the time to answer them properly, but I'll try to follow up with you afterwards. But yeah, shoot me an email if you've got a question about getting started with any of these tools, a question about Corelight, any question about resources. I'm happy to point you in the right direction and be of service where I can. So with that, thank you for attending today's webinar. I think given the poll results, I hope that a majority of you kind of learned a bit about new open source tools that you didn't otherwise have experience with, although a lot of you sounds like Wireshark users, which is great. Sometimes you need to go to that packet level detail to get to the bottom of your investigations, absolutely. But technologies like Zeek, like Suricata, like Elastic, all together can make kind of your packet analysis even better. Zeek can help you get to the packets you want immediately. Zeek can help you collect less packets because you can be more targeted in your packet collection. There's a synergy, and I know that's a buzzword and a bad word, but there really is a synergy to these tools. Once you put them together, they can make each other better and advance your organization. So thanks for the time. Thanks for dialing in. And yeah, a recording of this webinar will be made available as well as the slide deck. So with that, I'll call it a wrap. Thanks, Jessica.
All right, thank you so much. So that's all the time that we do have for today. Thank you to our speaker, John, for that great presentation, and to Corelight for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again for the next SANS webcast.